Okay, we are currently in our Mac VS Code. So today we are going to implement the 4x1 mux. So let's start it. We will declare the module mux 4 to 1. Now we will declare our ports. Our ports will be now 4 to 1, so there will be 4 input ports. So instead of using I0, I1, I2 for the lengthier approach, we can use the array this time. So we will use input 4-bit array and let's name it as I. Now input we have a 2-bit s because 0 to n minus 1. So it is 2 to the power 2. So 0 and 1 only selection lines. So selection lines. And output as expected 1-bit out. There are multiple ways to do it. Let me just write and module and then we will start. First is data flow modeling. You can use a way that is out. You can write as cell is 2b00. Is it 2b00? If it is, so 0 we can assign it as I0. Sorry, here should be a question mark. We are using the ternary operator game. Is it now? This time we will ask is cell equal to 2b01. If that is the case, assign I1. Once again not matching, we will assign cell equals to 2b0 to be 10. Is it? So we will assign out as I2. Still not. We will if for the last case there is only one thing left, so we will say I3 and we will end it. So it will check automatically if selection line has a value 00. If it is, we will assign the low LSB of I. If it is 01, we will assign the I 1 bit, and the same way it will keep on going. So let us go here, create a test bench. We will do mux 4 to 1 underscore test bench.v. You can clearly see I have created a lot of projects for you. I have added all of them in the GitHub repository. You can access them and check. Verilog is very easy. You just need to practice. Once you are used to it, you move to the sequential circuit, create finite state machine, create edge detector, pattern detector, and or sequence whatever you say. Then you can go to the CISO PISO operations. Then you can create a FIFO and LIFO buffer types lists there also. Okay, so there we do time scale to include and our file mux 421.v and let's move ahead. Let me give spacing for the beauty. 1 second, there is one problem. Let me clear it out. Yeah, fine. So let's declare our module mux 4 to 1 underscore test bench. Let's get some variables. So the first variable is reg. We have this 4-bit I, then we have reg selection line, then we have a wire out. Selection line is 2-bit now, so it will be 10. So that's it. Now we need to instantiate our module, so we just write the name of mux 4 to 1, design under test or unit under test, uh, dot I2 I, comma dot shell dot out. So we instantiated our module. Let's write the initial block and we will be end. Let me write end module here. Let's do what, for the initial case, let's say I is 4b0000, and cell is also, selection line is also, let me give some space, 2b00. Okay, then we had here monitor to display our value. We choose I equals to percentage b, then we have a selection line equals to percentage b, then we have finally the output equals to percentage b. Now we give I comma cell comma out. Now let's give some values to them. Let's say we have a cell equals to 2b00, and I is 4b101. Let's say it is choosing the lower bit now, so we will just do what, 0001. We will just make sure it is working fine at the each and every case. Okay, so we will check each and every case. So 00 is 01, 0001, 10 11. So this time I will give 10. This time it will choose this third bit now. This time it will choose the MSB. So that's it. And after some delay, we will just do a finish. Let's see if everything is fine. We declared cell and die. Okay, let's go to the terminal and write our code. I Verilog for execution. I Verilog we have a marks out dot pvp, and we have a marks 421 underscore testbench dot v. Using system Verilog and bit vectors test b 21. Any problem? 21. One second, I guess. Any problem? Cell and this. Why is it causing problem? Unbiased system Verilog literal cannot have a size. Mux 421 underscore testbench dot v 21 22 23 24 21 22. This line is creating problem. Let's see if I declare them in a correct manner. Here 4 to 1. Let's see if I've ever made a 4 cross 1 mux, because it might be overlapping with my original function. If not, we not added it. So input output here. This I equal to this, that is this, and dollar monitor this, cell is this, I is 1 2 3 4, cell is 2 bit, this is 4 bit. Malfunction using system Verilog, but I am not using system Verilog. Why is it saying that? Let me see. I Verilog. Oh, mux out baby mux 421 underscore test dimension mux 421 dot we included this file. System can be doctor at least it is to remove the warning by the 1 second. I let me just call this as detector. We have a say what's the problem in this code. Let's ask the GitHub Copilot whether what's the problem in this syntax in your test bench code assignment and similar, but Verilogs for literal. Did I for okay now I got it. I forgot to write here B. Ah shit. Let's clear this terminal. Write it here again. Then VBB and mux out dot VBP. That's it. I is this cell is 00, so it will choose the 0 bit. Uh, Initially everything was 0, so this was the just initial case, so it don't just need to consider it. So here we have 00, so choose 1 0 1. So every output is 1. Let's add some other test case also, so it will give whether it is working fine or not. Let's replicate this block once again. This time it will not give the exact same value. It will give let's say 1 0. It chooses the first bit. Let's give 1 1 here. Let's give 1 0 here. Let's give 0 1 0 here. That's it. Let's see whether it predicts the correct output or not. So we have a 0 0, so that's the 0 1 first bit, so these 4 are 1, so that's it. So from here let's see, it will check the 0th bit. Yeah, 0th bit is 0, so it will give 0. It will check the first bit. Yeah, first bit is 1, so it will give 1. It will check the second bit, so second bit is 0, so it gives 0. And it will check the MSB is also 0. So we successfully implemented the 4 cross 1 in this lecture. Thank you.